What if a black hole entered our solar system? Imagine a distant, silent darkness moving through the endless void of space. A black hole, invisible to the eye, yet monstrous in its gravitational might. It drifts on a path that, against all odds and probabilities, leads directly into our home, the solar system. The sun, the planets, the asteroids, comets, dust, and gas, all the familiar elements of our astronomical neighborhood, suddenly find themselves under threat from one of the universe's most enigmatic and destructive forces. But what would actually happen if a black hole entered our solar system? How would we detect it? What would the consequences be for Earth and for humanity? What catastrophic, but also scientifically fascinating, events would unfold as such an object invaded the ordered ballet of the sun and its planets? To understand the magnitude of such an event, it is first necessary to grasp what a black hole is. A black hole is not simply a hole in space, but a region where the pull of gravity is so immense that nothing, not even light itself, can escape. This gravity comes from a concentration of mass compressed into an incredibly small space, typically formed when the core of a massive star collapses at the end of its life cycle. There are different types of black holes, from stellar mass varieties, just a few times the mass of our Sun, all the way up to the titanic supermassive black holes found at the centers of galaxies, weighing millions and even billions of solar masses. For the scenario of a black hole entering the solar system, let us imagine a rogue stellar mass black hole, perhaps 10 times more massive than our Sun. Such objects are thought to be wandering the galaxy, born from ancient supernovae, and cast adrift from their original stellar nurseries. Long before the black hole arrived, its presence would have been suspected not by its appearance, for it emits no light, but by its effects on nearby stars, and, eventually, the planets of our solar system. Many black holes are detected in this way, by the wobble of objects orbiting an apparently invisible mass, or from the X-rays emitted as matter is drawn into their accretion disks. But a solitary, wandering black hole that has not yet begun to interact with solar system debris would be almost undetectable until it came alarmingly close. The journey would begin at the outermost fringes of the Oort cloud, a vast spherical shell of icy bodies orbiting the sun at distances up to 100,000 astronomical units. 1 astronomical unit, or AU, is the distance from Earth to the sun. Here, the gravitational influence of the sun is already faint. The black hole, dark and silent, would approach among these ancient remnants left over from the formation of the solar system. Its gravity would exert a subtle but significant force, stirring up the Oort cloud. Vast numbers of icy bodies would be nudged onto new trajectories. What would this mean for us? The first clue that something extraordinary was happening might come decades before the black hole's closest approach to Earth. Astronomers monitoring the sky might notice that the population of comets entering the inner solar system suddenly surges. Cascades of icy nuclei, each perhaps a few kilometers across, would begin to streak sunward, some lighting up the night sky as spectacular comets, others burning up in the sun or plunging harmlessly through the void beyond the planets. But the sheer number of them, hundreds, thousands, tens of thousands, would be unprecedented. Some of these comets might impact planets. The odds are low for any individual comet to hit Earth, but with so many more bodies in play, the threat of devastating impacts would spike, raising alarms among astronomers, planetologists, and all the world's space agencies. Fears of mass extinctions, akin to the one that ended the dinosaurs, would not be unfounded. As the black hole moved closer, its effects would grow more pronounced. At tens of thousands of AU, its gravitational field would begin to disturb the scattered disk, the Kuiper belt, and the more distant dwarf planets. Pluto, Eris, Sedna, and other distant members of the solar system would find their orbits subtly altered, perhaps becoming more elliptical, or even being thrown out of the solar system altogether, set adrift into interstellar space. Over years or centuries, as the black hole drew nearer, the precision observations of planetary orbits would reveal growing irregularities. The outer planets, Uranus, Neptune, would show unaccounted-for deviations in their motions. For years, these anomalies might be dismissed as measurement errors or perhaps attributed to as yet unseen small planets or asteroids. But as more data accumulate, a picture would emerge. Something massive, yet invisible to telescopes, is approaching. Once inside the orbit of Neptune, the black hole's presence would be undeniable. The gravitational perturbations would become dramatic. Neptune might be pushed onto a new path, its vast elliptical journey altered by the stealthy newcomer. The pattern of moons and rings around the gas and ice giants could become unstable. Some moons might be ejected, colliding with other objects, or flung into darkness. At this point, both astronomers and the general public would be gripped by a mixture of fascination and terror. News headlines would proclaim the coming black hole and speculate on its proximity and trajectory. Detailed modeling would quickly become a top scientific priority. Would the black hole pass by at a safe distance, or would it cut a swath of destruction through the planetary orbits? Let us imagine, for the sake of cosmic drama, that the black hole's path would bring it through the inner solar system, perhaps between the orbits of Mars and Jupiter. As it entered the main asteroid belt, the effects would be nothing short of cataclysmic. The myriad bodies composing the belt would be hurled onto new courses, some ejected from the solar system, others sent careening toward the inner planets. The risk of catastrophic impacts with Earth, Venus, or Mars would soar. Even at this stage, detection would still be indirect. The black hole itself would remain invisible, its event horizon shrouded in perpetual darkness. But as it passed through the debris-rich environment of the asteroid belt, some larger asteroids might be torn apart by tidal forces, the difference in gravitational pull between their near and far sides. If the black hole possessed an accretion disk, a swirling torus of gas, dust, and disrupted material drawn inexorably toward the singularity, this disk could begin to glow, emitting X-rays and powerful jets as matter is crushed and heated to billions of degrees. Telescopes trained on the region would soon observe this burst of high-energy radiation. Now, the danger to Earth would be immense and multifaceted. First, there is the threat of secondary impacts, flurries of asteroids and comets, unmoored by the black hole's rampage, slamming into our planet. In the worst scenario, a rain of impacts could trigger planet-wide fires, tsunamis, choking dust clouds, and a collapse of agriculture, a replay of previous mass extinction events, but on a perhaps grander scale. There is also a more existential threat, the possibility that the black hole's passage could perturb Earth's own orbit or that of the Moon. If the black hole passed close enough, within a few astronomical units, it could nudge Earth into a more elliptical path, potentially moving us farther from or closer to the Sun. Inward, and our world would become unbearably hot, oceans boiling off into space. Outward, and the planet would freeze beneath an eternal winter. If the Moon's orbit was destabilized, it might crash into Earth or be ejected into space, disrupting tides, seasons, and the rhythms of life that have governed our biology for millennia. Some scenarios, though less likely, are even more apocalyptic. If the black hole came extremely close, within the orbit of Earth or Venus, its tidal forces might rip the planet apart. Earth, reduced to a cloud of superheated rock and iron, spiraling inexorably into the infinite night of the event horizon. In such a case, all traces of human civilization, all the stories of our past, and all our future potential would vanish into the black hole, erased from the observable universe. More plausibly, if the black hole passed through the solar system at a moderate distance, missing Earth by several astronomical units, it would still fundamentally reshape the system's architecture. Orbits would be shifted, planets could be ejected, and the delicate balance that has allowed life to flourish on our blue world could be thrown into chaos. Consider Jupiter, the solar system's giant protector. Its immense mass has, for billions of years, deflected or absorbed comets and asteroids that might otherwise have struck Earth. But if the black hole's gravity perturbed Jupiter's orbit, the planet could move into a collision course with the Sun or be thrown out into interstellar space, robbing Earth of its cosmic shield. Perhaps the black hole would pass close to the Sun itself. Its gravity could tug at the Sun, causing it to move slightly through space or interact in complex ways with the gas and plasma on its surface. In a dramatic close encounter, the black hole could siphon off some of the sun's mass, forming an incandescent accretion disk, or, conversely, plunge straight into the sun, merging with our star in a cosmic cataclysm. Such an event would flood the inner solar system with radiation, likely sterilizing the planets. The timeline for all this depends dramatically on the speed of the black hole. Most likely, the black hole would be moving at tens or even hundreds of kilometers per second, a pace fit for crossing the entire solar system in years to centuries, depending on its trajectory and initial point of entry. For us on Earth, the approach and passage would be an extended ordeal. There would be decades, even centuries, of mounting instability. Cometary barrages, shifts in planetary orbits, strange apparitions in the sky, and, perhaps, slow-growing dread as calculations spelled out our fate. Throughout all this, humanity's ingenuity and adaptability might come to the fore. Astronomers and physicists would use every tool at their disposal, from gravitational wave detectors to deep sky surveys, to track the black hole's movements and refine forecasts. If impacts seemed likely, efforts to deflect or destroy incoming comets and asteroids would accelerate, perhaps uniting the nations of Earth in a common purpose unrivaled in history. People would gaze up at the night sky, searching for clues to their fate. The black hole itself would be invisible, a blot of perfect darkness against the stars, but its presence would be inferred from the chaos it unleashed. New mysteries would abound. How did the black hole come to intrude upon our system? How many others lurk unobserved in the galaxy, waiting to wreak random havoc on civilizations yet to rise or fall? Of course, there is a possibility, however slim, that such a cosmic visitor might pass through our system with comparatively little effect, skirting the outer planets and swinging back into interstellar space, leaving only subtle changes in the solar system's order. In that case, scientists centuries from now might point to tiny oddities in planetary orbits and reconstruct the drama long after it had passed. But let us also imagine the best in humanity. As the immediate dangers recede, the black hole could become one of the greatest astrophysical opportunities in human history. The passage of such an object would provide a chance to study black holes up close, something that would otherwise require journeys out to the remnants of faraway supernovae or deep galactic cores. Probes could be dispatched to observe from a safe distance, to study the gravitational lensing of starlight around the black hole, or to monitor the radiation streaming from its accretion disk. Our knowledge of gravity, spacetime, and high-energy physics would be transformed. Human curiosity would not be stemmed by fear alone. Writers, philosophers, artists, and poets would wrestle with the meaning of such a visitation. The black hole, in mythic and scientific terms, would haunt the human imagination for generations. It would remind us of our vulnerable place in the cosmos, of the silent threats that can emerge without warning, and of the extraordinary physical laws that govern reality itself. Looking back across the eons, there is evidence that the solar system has survived close encounters before. Ancient impact scars on the moon and the planets, disturbed orbits in the outer system, and the odd tilted tilt of the sun compared to the planetary plane, all may hint at previous disruptions by passing stars or rogue objects, though perhaps never one as powerful as a black hole. Over an even longer scope of time, the unpredictable crossing of black holes may be the ultimate fate of many planetary systems. As stars age and die, as galaxies twist and tangle, rogue black holes will become ever more numerous. Already, theorists estimate that hundreds of millions, even billions, of black holes drift unseen through the Milky Way, most far smaller than the supermassive giants, but still capable of chaos on a local scale. For now, our distant black hole remains a speculation, a phantom in the mind of scientists and storytellers alike. But out in the dark, beyond the reach of sunlight, cosmic wanderers continue their tireless journeys, shaping the universe in ways we have only begun to comprehend. Let us end by considering the lessons of such a scenario. First, it underscores the need for vigilance, to constantly scan the skies, to improve our ability to spot not only asteroids and comets, but the more sinister threats that may approach in silence. Second, it reminds us of the fragility and the interconnectedness of life, technology, and civilization on this planetary oasis. A black hole's careening path could unite or divide us, depending on how we choose to respond. Finally, it fuels our sense of awe at the scale and strangeness of the cosmos, pushing us to deeper understanding and perhaps to greater humility in the face of the infinite. If a black hole were to enter our solar system, the consequences could range from minor perturbations and increased comet and asteroid impacts all the way to the potential destruction or ejection of planets themselves. The timescales would be long, the dangers immense, and the outcome profoundly uncertain. Yet through it all, the human drive to observe, understand, and adapt would remain one of our species' defining characteristics. So, as we gaze up at the night sky, we can take comfort in our current good fortune and use the knowledge born from such speculations to better prepare for whatever wonders or terrors the universe has yet to reveal.